Saxon Algebra 1, Lesson 22. In this lesson, we review numerical and algebraic expressions, and we discuss statements and sentences and conditional equations. Numerical and algebraic expressions. Each of the following expressions, 4, 6 plus 3, 4 times the quantity 2 plus 3, 7 times the quantity 8 plus 4 divided by 5 plus 2, is called a numerical expression because it consists of a meaningful arrangement of numerals and symbols that designate specific operations. Every numerical expression represents a particular number, and we say that this number is the value of the expression. The values of the expressions above are given in red. We use the words algebraic expression to describe both numerical expressions and expressions that contain variables. These are all algebraic expressions: 6, x plus 4, x squared minus 6, and x times the quantity x plus 4. The value of the first expression is 6, but the values of the others depend on the value of x. If we assign x the value of 3, then the values of the other expressions are shown in green. Now we consider statements and sentences. If we wish to make a statement that certain quantities are equal or not, we can do so by writing a grammatical sentence in English. For example, the number of peaches equals the number of apples. Mathematically, we can write n sub p for the number of peaches equals n sub a for the number of apples. Or maybe the number of peaches does not equal the number of apples. In that case, we can write n sub p is not equal to n sub a. Perhaps the number of peaches is greater than the number of apples. Mathematically, we can write n sub p greater than symbol n sub a. If the number of peaches is less than the number of apples, we can write n sub p less than symbol n sub a. These mathematical statements are shorthand for the English statements above them. The three symbols, not equal to, greater than, and less than, are inequality symbols and are used in the same way as the equality symbol equals is used to make mathematical sentences. Thus, these three constructs are called inequalities. N sub p is not equal to n sub a, n sub p is greater than n sub a, n sub p is less than n sub a. Whereas this construct is called an equality or an equation. N sub p equals n sub a. The subscripted letters n sub p and n sub a can be used as variables in the same way that single letters like X and Y can be used. An equation is an algebraic statement consisting of two algebraic expressions connected by an equals sign. Each of the following is an equation and therefore a statement or sentence in algebra. 2 plus 2 equals 5. 2 plus 3 equals 5. 9 minus x equals x plus 3. X plus 2 equals 5. 7 plus x equals x plus 2. 2x equals x plus x. Those are all statements. Some of them are true statements. 2 plus 3 equals 5 and 2x equals x plus x. Those are true. Others are false statements. 2 plus 2 equals 5, 7 plus x equals x plus 2. Those are false. And some are conditional statements, since they could be true or false depending on what value is assigned to x. The conditional statements that depend on x are 9 minus x equals x plus 3 and x plus 2 equals 5. If x is equal to 3, then the green statements are true and the red statements are false. Replacement values of the variable that turn the equation into a true statement are called solutions or roots of the equation and are said to satisfy the equation. For example, if the equation is x minus 3 equals 7 minus x, then the number 5 happens to be a solution since 5 minus 3 is equal to 7 minus 5. They both give 2. Another way to say this is 5 satisfies the equation. We can also say that 5 is a root of that equation. We mentioned before that the equation 2x equals x plus x is a true equation. What this means is, no matter what value we assign to x, 2x will always equal x plus x. For example, if we replace x with 7, then we have 2 times 7 equals 7 plus 7. And this is true because we get 14 equals 14. Equations like this are called identities. An identity is an equation that is true no matter what value is assigned to the variable. Which of the following numbers satisfy the equation x squared equals x plus 6? 3, 2, or negative 2? First, we try x equals 3. Then x squared equals x plus 6 becomes 3 squared equals 3 plus 6. We must substitute the 3 everywhere we see an x. Well, 3 squared is 9, and that does equal 3 plus 6, so this is true, and 3 is a root. But we don't stop there. We also try x equals 2. Then x squared equals x plus 6 becomes 2 squared equals 2 plus 6. Well, 2 squared is 4 and 2 plus 6 is 8, and so that one is not true. 2 is not a root. Now we try x equals negative 2. Then x squared equals x plus 6 becomes negative 2 squared equals negative 2 plus 6. Well, negative 2 squared is negative 2 times negative 2, that's positive 4, and negative 2 plus 6 is equal to 4. So this one's true, and negative 2 is also a root. So both 3 and negative 2 satisfy this equation. But it is not an identity because 2 does not satisfy the equation. In fact, there are only two numbers that do work here. This is the end of Lesson 22. Your assignment is problem set 22 on pages 97 and 98 of your book.